In this video, we are going to solve a problem in canonical form of hyperbolic PDE. Consider the trichotomy equation uxx plus x uyy equal to 0, x less than 0. Find a mapping q equal to q of xy, r equal to r of xy that transform the equation into its canonical form and hence represent the equation in the coordinate system q, r. The problem is to find a mapping q equal to q of x comma y, r equal to r of x comma y, such that the mapping transform the equation uxx plus xuyy equal to 0 into its canonical form, and hence we have to represent the equation in its canonical form. We can start answering the question. We have given lu equal to uxx plus xuyy equal to 0. I number this equation as 1 and also given x less than 0. Now we have to determine the type of this equation, so we consider discriminant delta of L, which will be equal to b square minus ac by definition of delta L, which will be equal to, here b is 0, so b minus a is 1 and c is x. This will become minus x, which is greater than 0 since x less than 0. Okay, so the given PD is hyperbolic. Now we have to find a mapping, actually a non-singular transformation q equal to q of x comma y, r equal to r of x comma y, such that equation 1 can be transformed into its canonical form. To find q of x comma y and r of x comma y, we have characteristic equations dy by dx equal to b plus square root of b square minus ac divided by a, and dy by dx equal to b minus square root of b square minus ac divided by a. These two equations we have obtained in the previous theorem. Here in this question, b is 0 and a is 1, c is x, okay, which will be equal to square root of minus x. Here in the second equation, we substitute functions a, b and c. b is 0 minus square root of a is 1 and c is x divided by 1, because a is 1, which will be equal to minus of square root of minus x. By solving these two differential equations, we will get q of x comma y and r of x comma y. So first we solve dy by dx equal to square root of minus x, which is a variable separable equation. So we can rewrite the equation as dy equal to square root of minus x into dx. Integrating both sides, we will get y equal to minus x raised to 3 by 2 divided by 3 by 2 into derivative of minus x. Derivative of minus x will be minus 1 plus a constant c1. Multiplying this by 3 by 2 and rearranging the terms, we will get 3 by 2 y plus minus x all raised to 3 by 2 equal to c, where c is 3 by 2 times c1. Okay, similarly we can solve the second equation dy by dx equal to minus square root of minus x, which is also a variable separable equation. So we can rewrite the equation as dy equal to minus square root of minus x dx. Integrating both sides, we will get y equal to minus of minus x all raised to 3 by 2 divided by 3 by 2 into minus 1 plus a constant dy. Multiplying this equation by 3 by 2, we will get 3 by 2 times y equal to minus x all raised to 3 by 2 plus 3 by 2 times d1. I'm taking minus x raised to 3 by 2 to the left side, so it will become minus x raised to 3 by 2 equal to 3 by 2 times d1, which is also a constant, substituting 3 by 2 times d1 by d1. So we have got two equations, 3 by 2 times y plus minus x raised to 3 by 2 equal to c, and 3 by 2 times y minus x raised to 3 by 2 equal to d. From the previous theorem, we know q of x comma y and r of x comma y will be equal to a constant. So I'm choosing q as this, q of x comma y as this. We have got this term is equal to a constant, so I can choose this term as q of x comma y and this term as r of x comma y, and q comma r will be our new variables. Okay, so we can write that therefore the new variables are given by q of x comma y equal to 3 by 2 times y plus minus x raised to 3 by 2, and r of x comma y will be equal to 3 by 2 times y minus x raised to 3 by 2. So we have answered our first question. We have got the non-singular transformation that converts the given equation into its canonical form. That is, we have got a new coordinate system QR in which the given PDE will be in canonical form. So we can define u of x comma y in terms of q and r. Now we have to convert the given trichotomy equation into its canonical form. Trichotomy equation is uxx plus x uyy equal to 0. So you have to represent uxx and uyy in terms of q and r. We have defined uxy equal to wqr. To find uxx and uyy, we have to find ux and uy in terms of q and r. So first we find ux, that will be equal to wqqx plus wrrx by chain rule, and also uy will be equal to wqqy plus wrry. We know q and r in terms of x and y, so we can substitute qx, rx, qy and ry in these two equations. Okay, so we can use q equal to 3 by 2 y plus minus x raised to 3 by 2 to find qx and qy. Qx will be equal to 3 by 2 times minus x raised to 1 by 2 into derivative of minus x, which is minus 1, and qy will be equal to 3 by 2. Similarly, we can find rx. Rx will be equal to minus 3 by 2 into minus x raised to 1 by 2 into derivative of minus x, which is minus 1. So this minus will become plus. Okay, and ry will be equal to 3 by 2. So substituting these in ux and uy, we will get ux equal to minus 3 by 2 into minus x raised to 1 by 2 into wq plus 3 by 2 into minus x raised to 1 by 2 wr. Similarly, uy will become, uy is 3 by 2, so 3 by 2 times wq plus 3 by 2 times wr. Okay, so we have found ux and uy. Now we can find uxx and uyy. To find uxx, we are going to differentiate ux with respect to x. For that, we have to use both product rule and chain rule. Okay, So u xx will be equal to minus 3 by 2 into 1 by 2 times minus x raised to 1 by minus 1 by 2 into derivative of minus x, that is minus 1, okay, into wq plus derivative of wq with respect to x into minus x raised to 1 by 2. So that will become minus x raised to 1 by 2 into derivative of wq with respect to x will be wqqq, qx we are using chain rule, plus wqr rx. And now we can differentiate the second term. We have differentiated this term. Now we are going to differentiate this term. Okay, that will be equal to 3 by 2 times derivative of minus x raised to 1 by 2 will be 1 by 2 into minus x raised to minus 1 by 2 into derivative of minus x, that is minus 1, into w r plus minus x raised to 1 by 2 into derivative of wr with respect to x, that is wrqx plus wrrrx, which will be equal to 3 by 4 minus x raised to minus 1 by 2 wq plus minus 3 by 2 times minus x raised to 1 by 2 into wqqx, qx will be equal to minus 3 by 2 times minus x raised to 1 by 2, minus 3 by 2 times minus x raised to 1 by 2 plus wqr into rx is 3 by 2 times minus x raised to 1 by 2 minus 3 by 4 times minus x raised to minus 1 by 2 wr plus 3 by 2 times minus x raised to 1 by 2 into wrq into qx is minus 3 by 2 times minus x raised to 1 by 2 plus wrr into rx will be equal to 3 by 2 times minus x raised to 1 by 2. Now we can rearrange the terms. Here we have 3 by 4 times minus x raised to minus 1 by 2, and here also we have 3 by 4 times minus x raised to minus 1 by 2. So taking 3 by 4 into minus x raised to minus 1 by 2 common from these two terms, we will get 3 by 4 into minus x raised to minus 1 by 2 into wq minus wr. Okay, now we can write this term. Minus 3 by 2 into minus 3 by 2 will become 9 by 4. Minus x raised to 1 by 2 into minus x raised to 1 by 2 will become minus x. So this plus become minus, and into wq. Now I am writing this term. Okay, that term will become 3 by 2 into 3 by 2, 9 by 4, minus x raised to 1 by 2 into minus x raised to 1 by 2 will become minus x. So this plus become minus wr. Now I am writing these two terms. We know wrq and wqr are equal, so we can combine these two terms. So we will get plus 18 by 4 x wqr. So this is our uxx. Now we calculate uyy. Uyy will be equal to derivative of uy with respect to y. We have uy equal to 3 by 2 into wq plus 3 by 2 into wr, which will be equal to 3 by 2 into wq plus wr. So we are going to differentiate this term. So uyy will become 3 by 2 into derivative of WQ plus WR with respect to y. Derivative of WQ with respect to y is WQQ QY plus WQR RY plus derivative of WR with respect to y, that is WRQ QY plus WRR RY. Okay, now we can substitute the values of QY and RY. QY and RY are equal to 3 by 2. So we will get 3 by 2 into 3 by 2 times WQQ plus 3 by 2 times WQR plus 3 by 2 times WRQ. WRQ is equal to WQR plus 3 by 2 times WRR. Taking 3 by 2 common, we will get 9 by 4 into WQQ plus 2 times WQR plus WRR. So we have got the UYY. So now we can substitute UXX and UYY in the trichotomy equation. UXX plus X UYY equal to 0. UXX is this and UYY by this. So equation 1 will be plus X into UYY. UYY is this term. Okay, so we will get 9x by 4 into WQQ plus 2WQR plus WRR equal to 0. Here we have minus 9x by 4 WQQ, and here we have got plus 9x by 4 WQQ. So we can cancel these terms. Similarly, here we have minus 9 by 4 x WRR. Here we have 9x by 4 WRR. So we can cancel these two terms. So the equation will become 3 by 4 times minus x raised to minus 1 by 2 into WQ minus WR plus 18 by 4x WQR plus 18 by 4x WQR equal to 0. Again, by simplifying, we'll get 3 by 4 times minus x raised to minus 1 by 2 WQ minus WR plus 2 times 18 by 4 x WQR, which will be equal to 0. We can cancel 2 and 4 and 18 and 2. That is, we have got 9x WQR plus 3 by 4 minus x minus 1 by 2 WQ minus WR equal to 0. This equation contains x. Actually, we want to represent the trichotomy equation UXX plus X UYY equal to 0 in W, Q and R. Okay, but here we have got an equation in W, Q, R and X. So we want to eliminate X from this equation. For that, we will be using these two equations. Number these equations as 2 and 3. From 2 and 3, we can represent X in terms of Q and R. So we can use 2 and 3 to eliminate X from the equation number 4. Okay, so we write that equation 2 is Q equal to 3 by 2 y plus minus x all raised to 3 by 2 and equation number 3 is r equal to 3 by 2 times y minus x raised to 3 by 2. From these two equations we will get q minus r. Subtract these two equations, we will get q minus r in the left side, and right side will be 2 times minus x all raised to 3 by 2. Okay, that is minus x will be equal to q minus r divided by 2 all raised to 2 by 3. Therefore x will be equal to minus of q minus r divided by 2 all raised to 2 by 3. So we can substitute x equal to minus q minus r divided by 2 all raised to 2 by 3 in equation number 4. Okay, so we will get 9 into minus of q minus r divided by 2 all raised to 2 by 3 into wqr plus 3 by 4 into q minus r divided by 2 all raised to minus 1 by 3. Okay, q minus r divided by 2 all raised to minus 1 by 3 into wq minus wr equal to 0. This equation is in canonical form of our trichome equation, but we can convert this equation into much more simpler form. For that we will be taking minus 9 into q minus r all raised to 2 by 3 from the terms on the left side. So we will get minus 9 q minus r all raised to 2 by 3 into the first term will become 1 by 2 raised to 2 by 3 wqr. I am taking minus 9 outside, so minus 1 by 9 into 3 by 4, I am writing 4 as 2 square, into q minus r all raised to minus 1 by 3 divided by q minus r all raised to 2 by 3, because I am taking q minus r all raised to 2 by 3 common. So we have to divide the second term by q minus r all raised to 2 by 3 into 1 by 2 raised to minus 1 by 3, that will become 2 raised to 1 by 3. Okay, into wq minus wr equal to 0. Now we simplify the terms inside the bracket, so the equation will become minus 9 into q minus r all raised to 2 by 3 into, I can write 1 by 2 raised to 2 by 3 as 1 by 4 raised to 1 by 3 into wqr minus, from here we can cancel 3, and 2 by 3 divided by 2 square will become 1 by 2 2 minus 1 by 3, that is equal to 1 by 2 raised to 5 by 3. So we will get 1 by 3 into 1 by 2 raised to 5 by 3 into wq minus wr divided by q minus r all raised to minus 1 by 3 divided by q minus r all raised to 2 by 3 will become q minus r is equal to 0. Again taking 1 by 4 raised to 1 by 3 common, we will get minus 9 into q minus r all raised to 2 by 3 divided by 4 raised to 1 by 3 into wqr minus 1 by 3 into 2 raised to 5 by 3 into wq minus wr divided by q minus r into 4 raised to 1 by 3, because I am taking 1 by 4 raised to 1 by 3 common. So I have to multiply the second term by 4 raised to 1 by 3, which is equal to 0. This equation is valid for all q and r. So either this term or this term equal to 0 for all q comma r. Observe that the first term may not be 0 for all q comma r, so we can conclude the second term will be equal to 0 for all q comma r. That implies w q r minus 4 raised to 1 by 3 divided by 2 raised to 5 by 3 is equal to 2 raised to 2 by 3 divided by 2 raised to 5 by 3. I am substituting 4 as 2 raised to 2, which is equal to 1 by 2 raised to 5 by 3 minus 2 by 3. That is 1 by 2 raised to 5 by 3 minus 2 by 3 will become 3 by 3, that is 2 raised to 1. Okay, so we will get minus 1 by 3 into 2 wq minus wr divided by q minus r equal to 0. That is, we have got the canonical form of the given trichotomy equation as wqr minus wq minus wr divided by 6 into q minus r equal to 0.